So welcome to webinar, everyone. My name is Sandrine and I'll be your host today. So the event will actually start in about 5 minutes or so. In the meantime, it'll be great to know where everyone else is dialing in from. So I myself, I'm dialing in from Grey, London. It was rainy before, it's not raining anymore. So that's definitely a positive. Kevin, where are you dialing in from?
So I'm in Southport, so the northwest of the UK, in a place called Birkdale. So if you golf fans, it's golf capital of the world. So yes, that's where I am.
There you go, golf capital of the world. Exciting. So everyone, if you're able to, if you're on the call, if you've already joined us and you're able to let us know where you're dialing in from, you can just simply do that by using the chat button. And in the meantime, we'll just wait, hopefully see your responses, and we'll start in about 5 minutes. Just want to say it's great seeing that we've got people from Boston, from Stockholm, from Paris, from Portugal, South Germany. We've got a whole world here. It's amazing. That's great. Welcome, guys. All right, guys, we're nearly there. We're just gonna wait a few more minutes. And yeah, it's really great to see where everyone's coming and dialing in from. And we've seen a lot of France, which is great. I feel like we need to do an event in France, Kevin. That's what I'm getting from this. Um, also, guys, I mean, if you also want to kind of share maybe what you want to get out of today as well, we'll keep an eye on that and try to incorporate that into our conversations. But yeah, just a few more minutes and then we will kick things off. So we are now at 3 on the dot. So we will wait, maybe give it another minute or so for people to be able to join us, but there are quite a few people on the call already, which is great. So yes, just a few more minutes and then we will start. David, thanks for sharing what you're interested in. That's great. Okay, I think we will get started. We've got quite a few people on the call already. So once again, thank you everyone for joining us today. It's really great to see you all here. So today we have our special seasonal theme session called Spring into Cloud Native Data Protection. So before we get started, I just want to let everyone know that the session is actually being recorded, but your audio has been muted. So if you'd like to submit a question for the speaker, simply use the Q&A button, click on it and type in your questions. And feel free to do this throughout the session if you like. And what we'll do is that we'll aim to address that, all your questions towards the end of the session. So without further ado, let's get started. Our speaker today is our very own Principal Solutions Architect, Kevin Jackson. So Kevin is responsible for customer engagement in EMEA and spends much of his time helping enterprises meet their data protection and DR requirements. He has over 20 years of experience in system architecture and engineering with backgrounds in Auto Trader UK and Rackspace. So Kevin is also an author who's actually written multiple books around OpenStack clouds and subsequently has been on the cloud native architecture journey through Kubernetes. Without further ado, over to you, Kevin.
Thank you very much, Sandrine. Yeah, hey everyone. Yeah, thanks for that introduction. Yeah, I have the wonderful job today. In fact, it's my day job of taking everybody through the wonderful world of Trilio and what that means for data protection, backup and recovery, migration of data in today's cloud native worlds. So I'll take you through a little bit of background into Trilio, where we began, and where we see the landscape. And then I'll take you more into the world of Kubernetes when we talk of cloud native data protection. I'll take you through what our offer looks like in terms of protecting workloads on Kubernetes, and then I will jump into a demonstration of Trilio for Kubernetes in one of our environments. So with that, I'll take you through who are Trilio. So we've recognized quite early on. It was in the world of OpenStack. As OpenStack was growing up, we recognized very early on that there's a huge disconnect in this world of backup and recovery, and how that applies to how people are consuming clouds and how they're generating data on cloud platforms. So, everybody on this call hopefully will recognize that, the traditional type of backup and recovery type solutions, they fall short when it comes to how people are consuming workloads on those particular environments. In other words, those environments are designed to be very fluid, and arguably so in the Kubernetes world, probably a little bit more fluid and more dynamic than the world where infrastructure as a service and OpenStack kind of like grew up in. But equally, it's all, there is a big need and a realization that the traditional ways of managing backup solutions just didn't fit into these particular paradigms. So of course, up came Trilio. So, in the early days of OpenStack, that's where we grew up. And I'll take you, very, very briefly through the world of OpenStack, but I'll say quickly moving into the world of Kubernetes. But regardless of any of the platforms that we protect in this cloud native way, we have 6 core tenets, core design principles of our product that fit with each of these cloud platforms. First of all, a solution for data protection, backup and recovery of cloud-based workloads should be agentless. If you think of the world of a user has come along, the world begins and ends within the tenant or namespace 4 walls. So they create workloads in their virtual machines or containers, virtual networking, virtual storage. The last thing they want to do is then try and work out, well, how do I have to treat this workload so a backup, or more so a recovery, makes sense? And the last thing they want to manage there is another piece of software on their environment, when that's not what they signed up for. They signed up for a space where they can dynamically create their workloads. So a product designed for protecting these cloud workloads should be seamless. It should be fully agentless. And so that's what Trilio Vault for OpenStack and Trilio Vault for Kubernetes is, of course. Should be non-disruptive as well. Again, same kind of mentality. These people are signing up for these cloud platforms, whether it's the EKS of the world or whether or not it's some service provider where behind the scenes, it's OpenStack. Again, the last thing you want is to start to accommodate those kind of like those old ways of thinking of like how I would manage my backup of my data on these particular platforms. Again, the end of cloud, let's be really honest, cloud was designed for efficiencies. And so Trilio Vault for OpenStack, Trilio Vault for Kubernetes is also non-disruptive. And what we mean by that, and I'm going into a little bit more detail, but what we really mean by that is the fact that it should just work. 2, it should work without interrupting service. Now, of course, there are nuances in this. There are obviously, scenarios where you may want a service to be disruptive, disrupted, I should say. In other words, to get a consistency of data. Of course, we fully support that, but out the box, more than happy to take, backups of your workloads so they are perfectly valid for recovery on wherever you need those workloads to be. I like to bring multi-cluster, multi-tenant, multi-namespace, and self-service all into the same buckets. They are separate design tenants, but they work obviously close together. What we mean by this is it's all about the user. It's backup as a service. So if you come into this world where you've got users coming along and you're fed up of hearing them that they have to put tickets into a ticket system, and then I don't know, whatever your SLAs are, maybe the best case is within 24 hours, and the data gets recovered again. That's not gonna last if you're trying to promote cloud and expand your cloud services in your world. So this is all about the user. This is all about the ability for users to self-serve within their own namespace, within their own tenants. So that means everyday users, a developer, these multiple operators can come along, protect their workloads, whether it's OpenStack, whether it's Kubernetes, and fully protect it. Anything goes wrong, they don't have to pick up the phone. Maybe they want to pick up the phone and speak to somebody whilst they've clicked on their self-service portal, just to have a chat. But ultimately, this is all about you as a user being able to self-serve your data protection needs. And we go so far as the fact that if and I can go through this in the demonstration, if a user has access to multiple, say, Kubernetes clouds, they can self-serve the recovery of backing up their data from one Kubernetes cluster and then doing the recovery to a completely different cluster, of course, providing they can authenticate and they've got all the right controls on the target cloud. Scalable, infinite scale. Obviously, infinite is a pretty big number, but that's what cloud is. So right from the very beginning, cloud is designed to certainly give the impression that it is infinitely scalable. So who are we at Trilio to hold back those architectural designs to say, actually, no, you need to accommodate your backup solution before you can scale any further? That is absolutely not the case. So with Trilio, we're part of the installation, we're part of the infrastructure, we're part of how you would operate these particular clouds. So we wouldn't get in the way when we talk about infinitely scalable. So if you think about your, say, your Kubernetes clusters, you may have, a cluster of 20 worker nodes today. If you want to scale to 40 nodes, to 80 nodes, to on-prem to off-prem, Trilio for Kubernetes, and obviously OpenStack are very equivalent. We just scale in line with how you would be scaling those platforms. In other words, you as an infrastructure team just think of those, scaling those clouds, and the software such as Trilio just scales along with your plans. And lastly, maybe we talk a little bit too much. I mean, I can geek out for days talking about the backup format that we have for Trilio, but ultimately it's open source. We have an open universal backup schema. Now that might mean much, from this one slide, but it has deep implications when we start to talk about scenarios where people are talking about archiving the backups. You flip to a world where we don't use an open universal backup schema, and by that, very specifically, and I'll reiterate, it's an open source format that we store our data into. If you have a proprietary format, what that means is you have to have somewhere, you have to have the keys to unlock that proprietary backup format. We're open source. That data that we create, that format that we use there is fully open source. So in the worst case scenario, look, I'm sat here in a Trilio hoodie, and I don't want this to happen, but if anything did happen to Trilio between now and forevermore, you can always get access to your data. It's in an open format, it's in an open source format, and that means that if you want to keep your data stored for decades, as some mandatory requirements are, you can guarantee that you can always get access to your data. And you know what? We've got all this 6 tenants, and we have this across all our platforms. I told you about OpenStack. I told you about Kubernetes. We actually support Red Hat virtualization today. That's outside this particular conversation for today. But if I showed you the innards of how we do what we do across all these platforms, they all meet all these different requirements. And what we mean by this, when I talk about this, and I talk about it in the context of OpenStack, and I talk about it in the context of Kubernetes, I don't want you to think that we're some kind of third party that you're used to, some backup solution that sits at the side that some other team has bought, and there's somehow some kind of connection into the world of OpenStack and Kubernetes. When we at Trilio talk about providing cloud native data protection, we're part of the actual solution. So when we talk around Trilio Vault for OpenStack, we're literally an OpenStack service. So if you're familiar with that world, and I am, as I say, as Sandrine said, I've had many years. In fact, I was around since the A release of OpenStack. And I know, look, obviously I'm young enough. You're probably questioning, am I old enough to know, OpenStack A release? And I am. But But we're just another service. OpenStack is just a whole load of different services. They have one job to do. Our job for OpenStack is to protect those workloads. We just light up as another one of those services. You can operate us with the OpenStack command line client. You can click on Horizon and actually self-serve your workload backup and recovery. And the same with Kubernetes. We're installed as an operator. I'll go into obviously a lot more detail on the Kubernetes front, but we're genuinely there as part of how you would want to operate a Kubernetes cloud. And so we're knee deep, we're part of what you would expect. So if we're talking upstream, OpenStack Collar Ansible, OpenStack Ansible, we're talking the likes of, you've got a Ubuntu or Canonical contract and you want to add in the likes of Trilio to back up those workloads. We're literally part of what you're used to. We support the Red Hat world. It's again, we support the major distributions, and we're literally part of that architecture. And when it comes to Kubernetes, we provide everything you need in a very easily consumable operator format. We provide you with the ability to orchestrate the installation of our operator. So in other words, you can have a world where you're rolling out your Kubernetes clusters, and we recognize that Kubernetes runs on the likes of OpenStack as well. So you can have the ultimate flexible platform, as the Open Infra Foundation calls the Loki platform, where you can have the scalable world of OpenStack managing the infrastructure of Kubernetes, which can also scale. And you can have all this with the commonality of how Trilio, behind the scenes using those 6 core tenets, provides backup and recovery for your workloads, all knee-deep integrated into these particular platforms. Now, as I say, I'm going to go on to the world of Kubernetes specifically as part of this. If you wanted to go down into more detail of OpenStack, in fact, if you want to go down into anything, if you want to just geek out and talk OpenStack and talk to, start to reminisce, more than happy to have a chat. But we've also got a number of events around the world where you'd see Trilio solution architects and engineers. We've got people at the moment in Barcelona at the Mobile World Congress, probably wearing bright green shirts as a guess, if you want to look out for them, if you're lucky enough to be there today. But we're also going to be at the Open Infra Summit in Berlin in June. Just checking my notes over in the summer in Berlin. So again, if you want to have more conversations, find us at those events. And at any point in time, of course, you can contact us, chat about, have me go through into more detail of any of these particular platforms, or any of our team of essays, go through any detail. More than happy to. We're proper geek out on how we do things behind the scenes, and we're really proud of how we do stuff. So with that aside, as I say, I'm going to go on to the world of Trilio for Kubernetes, if my keyboard would work. So if I just go back one, there we go. Lovely Bluetooth. So Trilio Kubernetes. So what is it? So we're going to go knee deep now into the world of Kubernetes specifically. So Trilio Kubernetes, we are an operator. We're packaged as an operator, which essentially just lights up some new capabilities for your Kubernetes platform. So at the moment, you are very versed in the ability to create workloads. You create your deployments, you create your pods, you create your storage, and the world is very happy. What we give you as an operator is now just to give you the ability to protect those workloads. So we have these new CRDs, custom resource definitions. So what that means is you can continue to operate your Kubernetes world, but still using the likes of the kubectl, or if you use an OpenShift, your OC command line client to manage your backups as well. So if you're used to kubectl get pods, kubectl get PVCs, you can now do kubectl get backups, kubectl, apply, your restores. So you can, again, we're designed from the ground up, knowing exactly where we've come from in the OpenStack world, what people expect, and how we're meant to do stuff for protecting workloads in Kubernetes. We now give you that as part of your standard workflow. And so what that means is you can, of course, put this into your pipelines, have that step in there where you're about to make a change to your deployment, I know, why don't we take a backup of that particular environment by orchestrating Trilio and then rolling out your changes. And if anything goes wrong, you're going through all your automated testing, roll back automatically and pull back from recovery using Trilio. That's all well and good. I mean, it's all about how we can operate stuff. And obviously I'll show you that during the demonstration, but that's so what? What do we protect? Well, we protect workloads. And that's what we've ever known, you know, from the OpenStack world to now, that's what we've known. It's the world of what is important to the users using this particular platform. So we'll protect deployments based on Helm. So if you're managing your applications through Helm, we'll protect those Helm-based releases. If you are adding different operators, new operators into the environment, we'll protect those operators. If you are deploying anything in the world and you are applying labels to the various objects, to the various tiers, to however you are laying out the different objects within your particular world, we can identify them and add them automatically to backups and dynamically. And same with namespaces. If you want to move one step back, instead of going down to the level of detail of saying, okay, I've got these 3 applications, or I now need to add in this 4th application to back up the namespace, back up multiple namespaces. And because of our open universal schema, this ability to take your workloads and essentially take them outside of this particular platform, store them on that open universal schema on what we call the target, it's one of the CRDs, makes it very, very portable and highly flexible. Again, one of the, you know, it's a key tenet of Trilio, but fundamentally, it's what Kubernetes should expect. This great portability of your workloads. We've now just solved the problem of being able to give your data highly, a way of making that very mobile and highly portable as well. And so that will become very apparent as we go through this. When it comes to additional details and additional features of what we protect, you know, we will back up those workloads. But if you have workloads in there like databases, something in there that requires a level of touch before we're about to make a backup of those particular workloads, maybe it's to flush the data to disk. We of course support a very flexible way of managing hooks, so we don't have convoluted clients or sidecars to invoke, you know, and execute things within your pods. We have a very elegant hook-based system, which allows you to say, okay, just run these commands and flush data to disk, for example. We support a wide variety of what we call transformations. We recognize the fact that you may have you might have deployed Rancher on-prem. Yeah, it might be on a virtual environment. Our virtual environment has some kind of storage that you know is providing all the the data to your pods. But you now got a requirement or a request, or maybe it's the disaster recovery target where those workloads, Kubernetes, remember it's meant to be portable, those Kubernetes workloads need to have recovery onto, maybe it's an EKS cluster, an AKS, Google, wherever it is. But with Trilio, whilst we know we've backed up those workloads and we back them up in a very appropriate way, there's a ton of information that we capture. And what we can do is then recover those workloads onto alien Kubernetes platforms, obviously providing it's CNCF based distribution. But that's the likes of EKS, AKS, some could be a Tanzu environment in a different data center. But we have the ability to transform that data. And I don't mean that we're going to go in and manipulate your the data in your database. That'd be disastrous. What we mean is the fact that we can change the fact that you were running in one environment, but it's now changed. And the recovery needs to run with, say, I don't know, the persistent volumes now need to be on an EBS-based volume, whereas on-prem might have been an OCS, ODF-based volume. We support all that. When it comes to compatibility certifications, you can see we're certified across the board. We've got great relationships with the likes of Red Hat and IBM. We have certifications all the time, and certainly validations for many of the other distributions when it comes to our product being able to run successfully and with absolute minimal single-click based installation process onto these different Kubernetes-based platforms. I touched on before the fact that, yes, absolutely, continue to use your kubectls, your OCs, your whatever to manage your backups, just like you're managing your pods. But if you prefer the user interface, we know the fact that there isn't really a standard user interface for Kubernetes. So at Trilio, we've given the fact that we have to intimately, in a very appropriate kind of security conscious way, but intimately know how your application is deployed, how it's made up, all the metadata, all the connections internally, how it runs and why it runs that way. Well, we have a management console which will discover your workloads, you as a user. So if you logged in as Joe Blogs logs in, has got access to 3 namespaces. That's what we discover and present to you in this particular world. It's not a tool solely designed to be executed and run by a backups team. Again, firmly in the world of, I own my Kubernetes deployments, I own my data, I own this particular namespace, I'm going to back up my stuff. Well, we give you the ability to do all this through a lovely easy to use user interface. Again, I'll show you this in the demonstration, of course, but it will discover your workloads for you, allows you to point and click, of course, to do your backup and recovery and migrations on disaster recovery across multiple clusters, all from a single pane of glass. And lastly, if you want to install this, absolutely go ahead. It's available on, the operator hubs, the various, places where you'd expect to find, operators. Easy to install process, whether you're using a Helm-based way of managing your installations, do a Helm-based installation of Trilio for Kubernetes, or you're using things like, I don't know, you might be using the likes of DigitalOcean. You can just click on the icon and have things all working and protecting your DigitalOcean world. So there's multi-cloud interface. So this isn't really meant to show this. It's more of a nice jump point to highlight exactly what Trilio for Kubernetes is. But if you logged into your TVK cluster, this is what you would be presented with. And again, I'll show you this in the demonstration. But this interface is standard. You just expose this like any other service, and you can expose it on any of your Kubernetes clusters. It is multi-cluster aware, so you can add in multiple clusters, manage this from a single interface. So it allows you to click on your cluster number 1, make a backup there and do a recovery to cluster number 2, for example. We do that across all these different distributions. So completely distribution agnostic. We're very storage agnostic, providing that the storage, of course, is presented through CSI. It's one of our requirements, the container storage interface. Thankfully, the Kubernetes world has moved on from this Wild West world of how data is stored, managed as various different methods of essentially mounting data volumes inside of pods. Thankfully, the CSI, the container storage interface, makes things a hell of a lot more sane. So that's our requirement. And then when it comes to writing out data, any S3 target or NFS export is what we store. And remember, we're going to be writing out to that open universal schema. So S3, whilst it's the official, unofficial kind of like standard out there for cloud-based storage. So any S3 based storage, whether that's your on-prem ECS, Ceph-based worlds, or it could be the genuine Amazon S3-based environment, we'd be able to write data to there. Or it could be traditional NFS-based environments. Now, you as a user gets to control those targets. So you as a user gets to say that this data will be stored on this bucket, or this data will be stored on this bucket and this NFS export. We don't limit where you're going to be storing your data. And completely, if we're distribution agnostic, of course, it naturally follows that we're cloud agnostic. The big players out there, recently were featured on the AWS cloud marketplace as a feature on there. So again, you can come along if you've got workloads, whether it's an on-prem based world or it's on off-prem based on the the standard Kubernetes managed services, you can install Trilio to protect those workloads there and migrate between them. And like I said, we protect all these in a very agnostic way. We don't dictate the fact that you need to have X, Y, and Z before we take a backup of your applications. We don't ask you to insert some strange labels in there for us to identify that that's a candidate for backing up. You as a user gets control of what you want to back up and what you want to recover. So when it comes to installation, of course, we want to encourage you to install this. So again, we make it as easy as possible. So whether you're using the big distributions out there, the very popular ones, obviously I've only highlighted a few here, but even if the logo is not mentioned on here, you know, at the end of the day, if you wanted to install this on your I don't know, that smaller CNCF-based Kubernetes distribution that, you know, has a strange logo, then go ahead, do a Helm-based installation. Again, incredibly easy. At the end of the day, what we're doing here is we're putting some extra software into your environment. We're giving that ability for a user then to use these extra CRDs, these extra CRs, like a backup and a backup plan and a restore and a target. And again, it's just a natural flow of how you would use backup and recovery. At the end of the day, we want to get out the way as quickly as possible as well. And of course, you know, that any talk of backup and recovery to end users of a Kubernetes world is kind of like you know, something that sounds like it's heavyweight. It's something like another team that should manage. That is certainly not the principles of Trilio Vault for Kubernetes. So what this gives you, so just as a very high level view of the world, so this gives you the ability to protect your workloads. It's all about you. It's all about that world where when I log in, this is what I care about. All the stuff around the infrastructure, that's not what I am particularly interested in. I'm interested because it makes my application run, but what I control and what I own is everything that runs within that particular namespace. That is what we protect. And so what we do is we write this out to those targets. Again, in that open schema, makes it very, very portable. We're taking this data and basically more or less deconstructing, you know, your application. We know how it's all made up. And so we store all that on that target. And so when it comes to recovery, we know what was required to put that application back the way it was, with all the correct metadata, with all the correct data associated with, and the number of pods, whether you've scaled up or scaled down. We'll know at that point in time what that exact environment looked like. We can do that onto the same cluster or to an alternative cluster. And that alternative cluster doesn't even have to be the same thing. You could be, you know, a world where you are doing upstream-based work. You've got to a stage now where management have got buy-in that this is the right platform for your workloads, and now we're going to move over to OpenShift, or you're moving over to Tanzu. You can use Trilio to back up those workloads and then migrate them over onto the second cluster, or third cluster, 10 clusters even, wherever it is, we'll be able to put those data back on there. And given the fact that ultimately we're talking about data portability, that's the fundamental thing with Trilio Vault for Kubernetes. Backup is just a feature of the data portability aspect and this application portability aspect. And so you start to uncover places where you can fit Trilio as part of these particular workflows. So in terms of as a hybrid cloud story, we're now helping solve the ability to get data from one place to another. If you are using disaster recovery and need an ability to recover workloads in a disaster recovery, that's precisely what Trilio is designed to do. So use cases, self-service, backup and recovery. So this much is very clear. You know, I'm a user of these particular clouds, whether I've authenticated to one cluster or to, you know, my 3 clusters. I want to just carry on, just, you know, head down, kubectl, get pods, you know, kubectl, apply, create. I can now do backup and recovery just using all those same workflows. I want to implement this as part of some kind of CI/CD workflow. So in terms of application mobility, there might be a world here. In fact, we've done talks on this as well. If you want to go Googling, or you can have a look at the Trilio.io website and have a look at the webinars that we've done there. We talk around the ability for us to be part of pipelines. We talk around the world of having us as part of, say, GitHub runners, where code gets checked in and then an automated action occurs. That automated action occurs for us is a backup action, for example, or a recovery action. Or a recovery action with a transformation. So think of a scenario here where you've got a developer on day 0, and you've got some production workloads. Day 0 application developer needs access to some good data. We can do take the workloads from production And then through the magic of our ability to do transformations, the ability to have us as part of an orchestrated pipeline, and then, obviously with, that an extra step in there for you to say, okay, this is my data. I'm going to automatically scrub all those email addresses out of this production data, and I'm going to give this to dev. And you can have that on a daily cyclical cycle, and that way dev has always up-to-date data. Disaster recovery, of course, I said before, we're taking those workloads, the stuff that we care about, or all the things that make, that run within inside of Kubernetes, we're storing that outside of the world of Kubernetes in this highly portable format. And then this gives you the ability then to do disaster recovery. Disaster recovery is essentially, I need to put these workloads and this data back and in a production state, ready to be serving traffic. We have a number of tools and a number of ways for you to satisfy that. And I'll take you through that during the demonstration. We've got a part of our user interface where we've got multiple clusters. There's the ability to do disaster recovery, take elements from one or workloads from one and then do recover to an alternative cluster. And of course, that's like migration. So disaster recovery and migration, obviously the same ballpark. What we're talking about here is this, we've got this engine, this Trilio Kubernetes engine, which allows this ease of being able to migrate applications and its associated metadata and its associated data to wherever you need that those workloads to run. The last use case, ransomware protection and recoverability. So, you'd probably, or maybe asking, why is that part of this particular talk? Well, ransomware protection and recoverability has its own special use case. We've seen, of course, recently that, the world of ransomware, it's one of those things which always hits the headlines, because the problem with ransomware is as soon as it infects typically like one installation, the very nature of the worm or the type of processes, it means it can easily infect other workloads. So it easily rises to the surface when it comes to headlines. But it's nasty and it's very, very easy to implement, and that's probably why this is front page news pretty much every other day, apart from, of course, in today's terrible world. But that, unfortunately, as an aside. But back into the world of tech, we have this world where the good known path to recover from the likes of ransomware is from your backups. Now, but there's some nuances when it comes to ransomware and recovery. So when it comes to, it's not just around backup and recovery. In terms of like ransomware, there are various things and various factors you've got to think of when it comes to a comprehensive solution to ransomware. So Trilio aligned itself to the likes of NIST, where they have various categories or phases as part of their identification and recovery processes. Now, where Trilio fits when it comes to ransomware is, of course, we're going to be able to recover your workloads. But that's the easy stuff. That's the low-hanging fruit. Of course we can do that. The scenario, though, are when backups get infected. Backups become the weakest link in the chain. So whilst the top level priority is, infect the workloads, encrypt those particular workloads. So if somebody comes along and pays me some Bitcoin to allegedly give me my decryption key. Nothing stops that attacker going, do you know what? I'm going to encrypt your backups as well. So we support a wide variety of tools and extra features to make sure that when it comes to a ransomware solution, we give you the ability to be always able to recover those particular workloads. So we can encrypt those backups. Now, encrypting backups obviously doesn't protect from a bad, actor coming along and then also encrypting with their key as well. But it does prevent the backup solution, that target that you're storing your backups on. Don't forget, we're taking copies of your data. That does not become the weakest link in the whole chain. In other words, there's, if an attacker has to go through 5 levels to get access to some data, but only 2 levels to get access to backups, guess what? They're going to go down the backup route to get access to that same data. So of course, we give you the ability to encrypt those particular workloads, but we also give the ability to make those workloads immutable as well. And that's very, very critical. So when it comes to recovery, you want to make sure that you can always recover from your workloads. If you can't recover your workloads, there's no point having a backup. And so we give the ability to encrypt individually those backups that are stored on various S3-based storage. So we don't encrypt, we don't mark the whole bucket as immutable. We individually set the immutability flag on the individual backups that we create. But further into this, and I say we've gone to more talks. We've got some more deeper level talks that go into how this works. But I will just say that we are an engine. We've got a nice UI. We fit with the standard workflow of the kubectls, the OCs. But if you just want to put yourself in the mindset that we're just part of the engine, that engine is Kubernetes. We're now something which you would just think it should just be standard as part of Kubernetes. So we're just part of the engine. You're already orchestrating, from start to finish, code check-in, a load of things run, and then out comes some production workloads. But if you take the world of backup and recovery, what we can give you in the world of ransomware is the ability to go, okay, we store in an open universal schema. So another check in the box for why we do this. That is accessible, obviously in a very appropriate, in a very secure-minded way, but you can get access to those backups. They're just in a very useful file format. And so you can secondary scan. You can always scan. So you get the ability now to have your production workloads. So you've now got a copy of your production workloads, also known as a backup. They're marked as immutable, they're marked and they're encrypted, but you can now scan them as well. And so you can always check against the live running production, against your backups. You can report on anomalies as well. So what I'm going to do now, I'd say we've got further talks. We've got tons of talks if you want to go and geek out further into these particular words. But what I'm going to do now is going to jump over to a demonstration. So this demonstration I am going to use today. I feel like in a Red Hat based world. So I'm going to do my demonstration on OpenShift. I've got 2 environments. I've got an OpenShift in one environment. I've got OpenShift in another. I'm going to take you through the familiarity of TVK itself, show you what you would get out of the box when you install this, and it only takes a couple of minutes, and you'd have what I've got in front of me right now, and then I'll take you through a backup and a recovery onto a different cluster. So hopefully the demo gods are on my side today. So let me just switch over to my world. So I'm going to bring up my browser. Hopefully you can see my browser. I'm going to bring up a couple of shells. I've got 2 blue shells here. And if I just clear these screens, just make sure that it's all good. I will just explain what this demo entails. So first of all, I have an OpenShift world. So for those not familiar with OpenShift, so OpenShift is Kubernetes and then a whole load of bells and whistles added on from Red Hat. Underneath it, it's 100% Kubernetes. It's just got a few extra objects in there, which makes OpenShift what OpenShift is. So this demonstration works across any Kubernetes-based environment, and so much so, I will be still using my kubectl command to show you some of the features. So you can see here, I've got one environment. I know it looks like I'm faking things, they're just labels on the screen, but I will tell you that this one has got something running in it in this particular namespace. There we go. So I'm in this particular namespace. That namespace is called Kevin J, by the way. I'm very original when it comes to namespace naming. And this one is, it's not called Kevin, that's not how you spell kubectl. It is kubectl and get pods. I'll have a look in this one, but this one, funnily enough, is called Kevin J Restore. I can't even spell my own name. So there we go. I can't even spell anything these days. So if I look in this particular namespace on the second cluster, I've got nothing running there. That target browser, by the way, is just one of our pods that enables one of the features that I'm about to show you. So I've got 2 separate environments and I've got 2 different namespaces. That's all I'm going to tell you for now. And it is OpenShift, but you can, for those that are, not fans of the OpenShift world, it's just all Kubernetes under the hood. So I talked around the user interface. So the user interface is what we know as the TVK UI. I won't test you at the end, but that stands for Trilio for Kubernetes user interface. I can log in various ways. I can log in by authenticating through OpenShift, and just for today, I've got, because I want to replicate exactly what here. I'm using my kubeconfig files, but I would end up in precisely the same way. I'm also logged in as the admin. That's not a requirement, by the way. I've talked so much about backup, as a service. Even admins have a requirement to back up things. Okay. So this is a world where I've just logged in. So I've just authenticated as normal. That's just like me authenticating to, I don't know, into Rancher, or on my command line, I'm just authenticating into this particular world. But you can see straight away that this user interface is populated. And straight away, you can see the fact that I've got various places to navigate. And straight away, you'll see the fact that I've got these namespaces that are visible to me. And so what we've done is discovered what this user has. And of course, I'm admin, so I've got access to a lot of namespaces. But this, it's told me that these are all the namespaces that are under my particular control. Now, I'm only interested in my own namespace, of course, because I'm just being quite selfish today. But you can see here, Kevin J, that's me, it's all green. So one of the things you'll see straight from the word go, you've got an ability to see what isn't being protected. Anything in there that's white is currently not being protected, or anything to do with Trilio. In other words, there's no protection applied to those particular namespaces. If I wanted to protect them, I would literally just click on them and then just go through the process and follow the wizard of creating a backup for these particular namespaces. It really is that simple. The one I'm really interested in is my Kevin J namespace, though, because I'm going to use that as part of my recovery, as part of my demonstration. So you can see it was green, so green is good. And then over on the right-hand side, you will see the fact that I've got a number of restore points. So every time I create a backup, so if I go through the process of creating a backup, then I will have another restore point available to me. Now, just to highlight the fans of the command line, and just to appease everybody on this call, what this means is, so I'm going into, on my shell, I'm going to go into the same environment that I'm going to see here on the left-hand side. I'm going to see it on the CLI view. And you can see here, in fact, I've already done the kubectl get pods view of the world. That's actually in the Kevin J namespace. And again, just to make sure there's no smoke and mirrors, it is literally that same namespace. Now, there's nothing in there that mentions anything about backups apart from this target browser, but you can ignore that for the time being. If I do kubectl get backups, then you will see the fact, again, just using your standard tools, I've got a number of backups that are available to me. And if I want to, because I'm admin, by the way, so if I want to just say, okay, what are the backups available in this particular namespace, then of course, your standard rules of kubectl apply, just add in the -n namespace at the end. So in here, I've got a number of namespaces, a number of namespaces, I've got a number of backups available. There's lots of them. That didn't show up before. What I'm showing you there is on when I did kubectl get backups is we have the ability to do different levels of backups. Remember I said before we back up labels, Helm-based releases, operators, and namespaces. Well, I'm in the namespace view over here. And I've got a number of namespace backups here. So if I do kubectl get, and if I just, very easy if I just go down to the level of just grabbing the namespace scoped backups, you can see that they match these restore points just here. Now, if I wanted to go and say, okay, well, instead of protecting this whole namespace, I've got a number of backups available, and I want to protect individual applications that are part of these particular namespaces, then I can go inside. So again, very familiar if you're used to any kind of cloud world where the namespaces get shown on the left-hand side and the objects get shown inside of that namespace. Well, it's exactly the same world here. And you can see here, I've got another green tile. This is my application that I am protecting. That is this application, kubectl get pods. And if you see here, I'm doing a label-based backup. So if I just hover over this a little, if I click on the browser, if I hover over this, the label will pop up and I can go down into further details of what's being backed up in this particular backup. That's the same as over here. I'm backing up anything that matches this label of app equals Kate's demo app. Again, very original. So, and all the PVCs, and if I just do the full thing, actually, PVC services, any of the objects that associated with that particular label, that's what we're backing up. And you can see I've got a number of application backups, scoped backups as well. And I can use any one of these to do recovery to back to this original cluster or to an alternative cluster. Now, if I went to create backup, I've got a backup plan. A backup plan basically says, what am I going to back up or where am I going to back it up to? That's already preset. I can go into details in the deep dive with any of you on the call at any point in time. It's just slightly outside the scope of this call for today, just in the interest of time. But if I did a backup, it would go through the motions of creating a backup. And what that would look like, I can show you this because we retrospectively show you all the logs very easily by clicking on them. It will go through that process of capturing what we call capturing the metadata, capturing the data, and then uploading those associated metadata and data to a particular target. And so you can see all the steps that occur as part of a particular backup. Now, I'm not going to do a backup. As you can see here, it takes a good few minutes. We've got better things to do, so I'm going to do a recovery instead. But I'm not going to do a normal recovery. On the left-hand side here, we've got the ability to add in multiple clusters. You can see the fact that I've got my existing cluster over here, and I've got a secondary cluster. This second cluster here, which is represented by this second shell over here. So it's actually a staging environment. You don't need to know that, but of course the words are on the screen. You can all read. But I've clicked on this second cluster, and it means I can now operate this as if I'm logged into that other cluster. In fact, technically I am logged into that other cluster. And you can see here, I've got access to all those namespaces that are on this particular second cluster over here. And I've just clicked on this Kevin J Restore namespace. And the reason why I'm showing you that is there's nothing there. And that's a clue to what I'm going to do as part of my demonstration, because that matches this. So if I just go here and just show you that for this particular namespace, for those same objects, so I ran that same command over here of what's running, just to really emphasize the fact that there's nothing running here. There's nothing here. Now, to do a recovery as part of this demonstration, what I'm going to do, I'm going to recover a backup from that original cluster, and I'm going to recover it to this second environment. So in this Kevin J Restore environment, we have a target. Now, this is the key, one of the key pieces. Well, one of the key pieces are the ability for us to have migratable and portable data. But in this particular scenario, we are writing out to basically this. We can read and write the same target backups. So what this means is I've got cluster number 1 writing out my backups to this particular target. It's an S3 based bucket, and I've got my cluster number 2 that can also see that same target. Now, that's not a requirement if you want to replicate your data across. So you've got target 1 in data center 1, target 2 in data center 2. Providing that we can read those backups, hey, we can read everything in there and do a recovery of that data. And that's the reason for that particular pod that was running in that particular namespace. There was what's known as a target browser running in there. That target browser allows us to have a different view of the backups available. So I'm on my second cluster. I can see all the backups that were created from that original cluster. And in this case, I'm writing out very specific backups to this particular target. And I can choose any one of these backups to do a recovery to my second cluster. So what I'm going to do is I'm going to do a recovery of this particular backup, and I'm going to do a restore to this particular cluster. So I'm going to call it this. I don't know. Just it's a namespace backup. You can do application level or whole namespaces. I'm choosing a whole namespace one. In our case, it'll end up in the same place. And I'm going to say recover this workload to this particular namespace. We have a number of flags that we can set that might be appropriate for your particular environment. I can skip the creation of metadata if it already exists. So again, it's all about working around various conflicts. I can rewrite or change, so patch some of that metadata. I can just recover the metadata, or I can just recover the data. So I have various ways of doing this particular recovery. If I click next, I have the ability to do transformations. I'm doing an OCP to OCP based recovery, so I've got no transformations needed. But if I, for example, and we've got plenty of demonstrations on this in previous demos, I can do recoveries from OpenShift to EKS or to AKS, and you'll know that there will be differences. My persistent volumes, say on OCP, might have come from OCS, and I need to create them on Google storage. And I can say for this PVC, use this storage class instead. So I don't need to do any of that. So I'm just going to have no types of transformations, and we're just going to do a straightforward recovery onto this environment. Now, this will take about a couple of minutes, and I'm looking at the time, and I apologize. This is pretty normal for Kev. It's well known in Trilio that I always go over time, and I'm going to really make sure that I'm not going to go over time, because I'll get told off not only by my sales exec, but I get told off by marketing as well now. So I am not going to go over time, but this recovery is occurring in the background. You can see it happening in real time here. And just for those people that like the command line, I'm going to do just show you that the pods are, oops, not this. I want to do it in this namespace, because that's what we're doing, the recovery. Because what we do at Trilio, the way we do our backups and recovery is we spin up pods. A pod will either go, I'm going to do a backup or I'm going to do a recovery. And so they spin up just in time. They do a type of job. And then once that job is done, it moves on to, that pod work is done, and the next pod spins up and does its job. And so this is now going through that process of this is the longest stage. It takes about a minute. Or it takes about a minute, and this is over in the US. So maybe it takes a little bit longer now that everybody's woken up. But essentially, this is taking that, the data we've stored in that open form. Oh, there we go, it's even quicker. And then it's putting that back. So the persistent volumes from, we stored on S3, it's creating those persistent volumes in this particular environment. We've grabbed the metadata from that target. We know exactly how this application was built like. We're telling Kubernetes, go and put this application the way it was when I took this back up, and here's the data associated with all this. And you can see here we've got a successful recovery. And if I just, my zoom is in the way here. If I just Control-C this, clear this, and just go back to showing you this particular application. Obviously, there's a few more elements in there, but this is the easiest way to show this. I didn't have this before. This was my second cluster, and I did a very simple recovery from one cluster to another, and I end up with my application running. So in the interest of time, what I'm doing is I'm going to see if we've got time. Sorry, Sandrine, to where am I going? I'm going to go here. Have we got time for questions? Maybe one or two.
Yeah, I think we can squeeze in a couple of questions. We've got some from the audience, but thank you so much, Kevin. That was really insightful. Thank you. Let me have a look and see which one we'll start with first. So we've got a question that's asking about the difference between Trilio Vault for Kubernetes and HashiCorp Vault.
Okay, so Vault obviously, has stores secrets. So if you've got specifics around backing up certain parts of the metadata, you can store as in HashiCorp Vault. It's a different level. Trilio is an all-encompassing solution. Trilio allows you to back up more than the secrets and some associated metadata for your particular workloads. We ultimately protect your applications, and we're protecting those persistent volumes. We're doing it in a very consistent way, and we're doing it in a highly portable way. So the two independent solutions, although we have actually ran POCs where we can also look at protecting HashiCorp vaults as well. And again, it's an object within the world of Kubernetes. And you've seen the fact that we do discovery, and we can protect these objects that are exposed to users.
Great. Okay, I'll read the next one out to you. It says, how does Trilio Vault trigger disasters, and what kind of DR are supported? Question mark. One site design? Question mark.
Okay, so hopefully we don't trigger any disasters. I mean, that'll be disastrous. Honestly, I don't have, you press that big red button and everything goes boom. So So yeah, you will see that we're an engine. There isn't a big red button. There isn't currently a big red button in terms of Kubernetes clusters. What we've got today is an engine which allows you to take workloads and then orchestrate the recovery to an alternative cluster. Now we've got things in the works, which obviously I won't be talking about if we start to talk of have a deep dive with us and go through NDAs. We can go through some of the plans that we've got to enhance disaster recovery with almost like big red buttons. However, again, see us as an engine, see us as the ability for the fact that we can discover your workloads extremely easily. That's just what it does. We create those backups and we have the ability to have those backups portable. You can replicate that data however you need to, just files and folders. They're just big files sometimes and a whole load of construction data around your application, and therefore we can recover that data. And the key thing about the recovery is the fact that all that is orchestrated. You're sitting in in a big command center or NOC somewhere, and you want to do a recovery of some workloads. You literally, if you've got a dashboard, you can say recover that workload. But we also support that notion of transformations, and I think that's also very valid and very important when people are thinking about disaster recovery. Obviously, in the old world, you had like data center 1, data center 2, and literally they're like lockstep. If you bought hardware for one, you would have hardware for another. In the Kubernetes world, it is designed to be more portable, of course. And again, we don't want to be the Achilles heel there in that kind of Kubernetes portability world. And so we do support the ability for you to recover those workloads. Even in a disaster recovery scenario, if you're recovering multiple workloads, multiple namespaces, and have them on another target cluster, and that cluster is completely different to what's on-prem, 100% supported. You can have these defined as essentially YAML files. I don't want that to scare you, but if you want to use the UI to generate those YAMLs, then you can have them in your library and literally say, execute this YAML on this target cluster. Very simple. Oh, you're on mute, Sandrine.
Yes, classic move.
Classic.
Never
for one more.
We will. Okay, let's squeeze in one final one. Okay, it's a question that's asking whether Trilio can be used as part of a CI/CD pipeline, and where does it fit?
Yeah. So again, in that same kind of like mentality, see us as this engine. This engine is something that you already have as part of your CI/CD pipeline. You're literally telling a system to go control something in Kubernetes, and it's just natural to say, okay, well, I want to spin up some pods. I want to create some volumes. It should be just an easy extension to say, well, I want to now create a backup. I want to now do a restore. It's just part of that same world. Now we have example GitHub Runner. So if you want to, obviously there's more things out there than Git, and obviously, if we're talking Argo CD, there's just another tool in the whole pipeline. But the principle remains is the fact that you are asking some kind of service to go and execute something else in the chain. That something else in the chain is now Trilio. So you can have this as part of your pipeline. You can say, go and do something before something changes. And that's something usually is protect this, because if something goes wrong, I need to revert, or I need to manipulate the data. Like I said before, I need to take my production workloads. I can use Trilio to go and grab that data from production. I can do a data only recovery back into say development. And then as part of that flow, again, this isn't out the box, but doesn't take a leap of the imagination to say, okay, I've now got this data. I've now recovered this single persistent volume. It's production data. I'm going to now mount it and scrub all the data, and then I'm going to hand this over to dev. So again, see us as part of the chain. We're tooling. We're designed from the ground up how I expect Kubernetes should be consumed.
Brilliant. Kevin, I think we'll probably call it a day at this point. Thank you so much again for all your insight. Hopefully everyone who joined us really enjoyed that session. There's no question I've come across that Kevin can answer. So please, if you have any questions that we haven't been able to answer, reach out to us via the details on the site, or sorry, on the screen, or via the email that we'll send out to you, and we'll be happy to answer any of your questions. So I said thank you for everyone who's been able to join us today and stay to the end of this session. Look out for an email from us that will have instructions on how you can go online and access your thank you spring gift from us. So once again, thank you guys so much for joining us. Kevin, thank you so much for all your insight. And yeah, we're going to conclude the program. Please go ahead and enjoy your day. Thank you, guys.
Thanks, everyone.
Bye.